I like teaching math when I get to tell the story. I've probably already told this story once before, but it's a good story, so you get to hear it again. All right, so write an explicit formula. So what's our explicit formula? Well, if you look at this, all right, notice is this arithmetic or geometric? It's arithmetic. What's your common difference? 3, right? Easy, right? So if your common difference is 3, then this is going to be a sub n is equal to 3n, and now basically fix it. So when I plug a 1 in, I better get a 1, so I'm going to subtract 2. And you can check it, like if I plug a 1 in, I get a 1. If I plug a 2 in, I get a 4. If I plug a 3 in, I get a 7. Yes, it works. For question 2, everybody okay? That's arithmetic. What's your common difference? Well, negative 9, right? Because you're going down by 9. So in this case, it's going to be a sub n equals negative 9n. Now you need to fix it, right? I need to make sure that when I plug in a 1, I better get a 10. Well, if I want a 1, I better get a 10. That's going to be a plus 19, right? Because if I plug a 1 in, negative 9 plus 19 gives me a 10. And you can check. Well, if I plug a 1 in, does it give me a 10? Yes. If I plug a 2 in, does that give me a 1? Well, negative 18 plus 19 gives me a 1. Quick check, and you got your answer. And more importantly, you didn't memorize a formula, right? Because yes, can you use your notes? Well, yeah, I can't stop you. But can you use your notes when you take the SAT? They don't exist, right? There's no notes. And we're a year or so away from that, right? And you're going to have, there are questions on the SAT that are dealing with arithmetic and geometric sequences, and I want you to have a working knowledge, not here's a memorized formula. All right, so now I get to tell probably one of my favorite math stories. And I'm curious, have I told the story about there was the kid in the class and the teacher said add up the numbers from 1 to 100 yet? Awesome. All right. So here's the setting, right? We're in the mid-1700s in Germany. One-room class, like the one-room class, like the one-room school where everybody's in the class. And the teacher got mad at the class. And so the teacher said, add up the numbers from 1 to 100. Meaning, what's 1 plus 2 plus 3 plus 4 plus ... plus 98 plus 99 plus 100, right? And so you have this, wide age, this wide gap, wide range of ages in the class, right? And the youngest, and also paper is expensive, so they're not using paper. They basically have these little bitty chalkboards, right? And so the teacher says, all right, add up the numbers from 1 to 100. And everybody starts working, right? And they start writing on their little chalkboard. Except the youngest kid in the class. And I don't know, different stories. Some say he's 5, some say he's 7. I'm just going to say he's 6, right? And the instant the question was asked, the little 6-year-old writes the number down on his little chalkboard. He takes it up to the teacher's desk, and he puts it on the teacher's desk, and he said, there it lies, in German. I don't know how you say that in German, right? And over the next hour, the rest of his classmates find this answer and put their little chalkboards on top. And so the teacher goes through and he's like, no, like all of them are wrong except that 6-year-old kid, right? And this 6-year-old kid was able to add up all of those numbers instantly, right? Now, that 6-year-old kid's name was a guy named Friedrich Karl Gauss, right? And Friedrich Karl Gauss actually goes down in history as the greatest mathematician ever, right? And this is kind of the first documentation of this little story. And so at this point, his math teacher realized he had a special student, okay? So this teacher tried to teach Gauss everything that he knew. And there's some other stories about Gauss. One was when he was 3 years old, he looked at his father's ledger, or basically his checkbook, and said, Father, you've made an error. So at 3, he could look and do arithmetic. And actually, as an adult, Gauss would say he could reckon before he could read. Basically, he could add before he could read. Like, he could always do this. Now, his teacher worked with Gauss until he could help, try to help him out as much as he could. And Gauss's father did not want Gauss to be a mathematician. Gauss's father wanted Gauss to go into religion, ministry. And Gauss's father asked the teacher, and he says, how good is Gauss? How good is my son? And the teacher said he will be the best in Europe, right? And actually, he was like the best ever. And Gauss, if you take upper level math courses in college, his name's attached to pretty much everything. I mean, he knew everything, and he was an expert in everything. Here's the kind of embarrassing part. I can explain what was going on in his mind when he was 6. I can't explain what goes on in his mind when he was 19. Do you remember when we were doing it's called the fundamental theorem of algebra, like if you have like x to the 4th plus stuff, that means you have 4 zeros. Like if you have a polynomial of a degree n, that means you have that many answers. He was one of the first people to prove that exists. I mean, that's a rule, right? It's a theorem, meaning you can explain why. He was one of the first to explain why. He did that when he was 19. When I look at it, like I've seen it, translated because I don't understand German, right? But even the translated part, I understand like the first 2 lines, and I don't know what he's doing after that. So when he's 19, I have no idea what he does. I can explain what he does at 6, right? So is anybody curious how a 6-year-old can answer this question instantly? Now, as I do this, I want to make sure you understand, no one showed him this trick, right? No one showed him this trick. I'm showing you the trick. He developed this trick the instant the question was asked. A 6-year-old did this. Right? Ready? So he looked at this problem and he said, all right, I got to add up the numbers from 1 to 100. And he said, I'm bored. I'm going to add it back. I'm going to write them down backwards. So I'm going to do 100 plus 99 plus 98 plus 97 plus ... plus 3 plus 2 plus 1. And now I'm going to add them together. Well, what's 1 plus 100? 101. What's 2 plus 99? What's 3 plus 98? 101. Do you see a pattern? Okay. Also, how many numbers do I have? If I'd written them all out, how many numbers would I have had up here? 100, right? So how many 101s am I going to have? I'm going to have 100 101s, right? But can we agree that that's twice what we need? And so what we're going to have to do is divide this by 2. And if you're curious, this answer is 5,050. A 6-year-old came up with that. The instant the question was asked. That to me is amazing. Right, can y'all appreciate that? Right? The embarrassing part is, yeah, I can explain what he knows at 6. Right? I got no clue what he did, at 17. Actually, at 17, what he decided to do, first of all, this guy was brilliant in everything. You ever met those people that just seem like they're an expert in everything? Right? That was Gauss. Like, he knew everything. He actually liked learning languages as a hobby. Yay. Not my thing, but right? So apparently he could speak 12 languages fluently. He didn't like Sanskrit too much. But anyway, so why do I tell this story? Well, this is my intro into what we're doing today. What we've done, what we were talking about before with arithmetic and geometric sequences. A sequence is when you just, it's a pattern. It's a list of numbers And it's arithmetic if you add to get to the next term. It's geometric if you multiply to get to the next term. Today we're going to talk about something called a series. And a series is when you add everything up. And believe it or not, this is an arithmetic series. This is about the most basic arithmetic series you could possibly have. Because if I just gave you the list of numbers, 1, 2, 3, 4, dot, 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 this is arithmetic. Do you see your common difference is 1? Can we agree that that's about the most basic arithmetic sequence you could possibly have? So if you add them all up, right? And when you add up a sequence, that's called a series. And today we're actually going to talk about an arithmetic series. Meaning, how do you add all this stuff up? We spent a couple of days talking about if something's arithmetic, how do you figure out the next term? Now we're going to talk about, okay, how do you add them all up? Got it? And I don't know, I always liked this story. I remember my mom told me this story. Although she didn't tell me, I didn't hear that it was a guy in the 1700s. I thought, when I heard the story, when I was in elementary school, or when I was in elementary or middle school, I thought it was one of her classmates because that's how my brain worked. And I said, really, did you have a classmate, as older, did you have a classmate that can do this? And then when I read the story, I said, no, she was just talking about Gauss. G-A-U, that's his name. All right, so everybody see how, right, so do we see how to add up the number from 1 to 100? Right? Well, let's talk about, how do you add up the numbers for a more complicated arithmetic sequence? Or add up the numbers for a complicated arithmetic series. So let's go back to that first example where I had 1 plus, where we had 1, 4, 7, 10, 13. I'm going to put a few more in 19. Our example 1 where I had said come up with this. And that was, if I just have commas, it's a sequence. But what I want is a series. So I'm going to add them all up. And so I want to know, how do you add these up? And I'm going to call that S. Actually, the reason I'm going to call it S is that's what your book does. And they're really creative about it. They call it S for sum. Okay. All right. So we're going to do Gauss's trick. Gauss's trick is, could you add these up? Yes, I know you could add these up, right? It's not that hard. You can do 1 plus 4. And actually, there's some tricks, like you can add these together. That's 20, 20, 20. There's some tricks to add them up. But what I want to do is I want to add them up the way Gauss did so that we can create a formula. And so Gauss's trick was, if you see this, right, write them down backwards. And so I'm going to do 19, 16, 13, 10, 7, 4, and 1. And we know that's S. And so what do we get? When I add these up, what do I get? Everybody see we get 20? How many 20s are we going to have?
7.
Does everybody see we got 7 20s? And so this is going to give me 20. I'm going to put the 7 here for reasons you'll see in a little bit. And that's going to be twice what we need, right? Does everybody see that? And so if that's twice what we need, we're going to divide by 2. And so here's what I know, is I know that the sum is going to equal 7 times 20 all over 2. Right. Is everybody okay with that? So everybody, right? Now, yes, that's nice. Great. I've got, I could solve it. But what I want is a formula, right? Because if you were to look up online or in a textbook or everything else, they always have a formula. And so I want us to create the formula, right? And when we create the formula, I want to make sure we understand the name of the characters, right? And so here's the names of the characters. N is going to represent the number of terms, right? And think about that. That a sub n, right? When we're dealing with sequences, like if I gave you a sub 7, that would tell you I want the 7th term. So n has always represented the number of terms. And I'm going to say a sub 1 represents the first term. Is everybody okay with that? Has a sub 1 always represented the first term? Right? So I'm not creating anything new. It's stuff we've been using. And then I'm going to say a sub n is going to represent the last term. And you got to figure out some way to represent the last term. And if you think about it, if I'm interested, like if this is when we had when we came up with our formula, remember that formula we did at the very beginning of class? I said a sub n was equal to, what is it, 3n minus 2? If I compute a sub 7, that would give me the last term, wouldn't it? Like if I plug a 7 in, that's going to give me 19. If this is your formula and I plug in a sub 7, whatever the last position, this is the value of the last term. So I guess technically, this is like the value of the first term and the value of the last term. All right? Everybody ready? Everybody understand the names? All right? These are names we've used, right? Yeah, the n is maybe a little vague at this point, but those are the names we've used. All right. So now let's figure out what goes here. What's the significance of the 7?
The number of terms.
Is everybody okay that n is the number of terms? And so I'm going to say that's an n, right? What's the significance of the 20?
The first term plus the last term.
Perfect. Does everybody see that the 20 is the first term plus the last term? I mean, technically, I guess you could say the second term from the second to the last, or the third from the last. But to make our lives easier, we're going to say it's the first term plus the last term. And so that's going to give me a sub 1 plus a sub n. And what's the significance of the 2? It's always going to be there, isn't it? Right? Because every time you do this problem, you're going to add it twice and divide by 2, aren't you? Does everybody see where that formula comes from? All right? And so now what I'm going to do is I'm going to write the official version of the formula. Everybody ready for the official version? The official version of this formula is S sub n is equal to n times a sub 1 plus a sub n all over 2. And so the only thing that's a little different is S sub n says this is like the sum of the first n terms. So if I want to know the sum of the first 7 terms, I'd say S sub 7. If I want the sum of the first 30 terms, I'm going to say S 30. Whatever this represents, right? Is everybody okay with our official titles? Now, if you've been in my class long enough, you may realize I'm not real big on official names. I like using general terms because, to be honest, when things get real technical, it's easy to forget, right? And so here's how I want you to remember this formula, right? I mean, this is what, if you look in a textbook, any textbook, you can type in right now, what are the sum of an arithmetic series? If you type that in, this will show up, right? Okay. But here's how I want you to think about it. I want you to think about this as, well, if I'm going to sum up an arithmetic series, I need 3 things. I want the number of terms times the first term plus the last term divided by 2. And it's been my experience, it's a lot easier thinking about it this way, right? Because if you look at this, you have to translate it. What does n represent? Oh, it represents the number of term. What is this? That's the first term. What is this? That's the last term. So the way I want you to think about how do you sum up an arithmetic series is you need 3 pieces of information, right? You need the first term, you need the last term, you need the number of terms. Everybody got it? Okay? And so today is all about an arithmetic series. So we're going to start with easier problems and work our way up to harder problems. Right? So an easy problem is I give you exactly what you're looking for. And just so I have board space, how far do I go? Wow, I can go all the way over there. Good. So I'm going to write my translated version, number of terms, first term plus last term all over 2. Okay, that's our translated. That's what we're going to use in class, right? And so let's look at some problems. So I want to know what is S of 25 if A sub 1 is equal to 31 and A sub 25 is equal to negative 100. So this is an easy problem. The reason it's an easy problem, I've given you everything. Right? You need 3 things. You need number of terms, first term, and last term. Right? What's your first term? Actually, let's do the order. This is the way I always think about it. I think I need my first term, I need my last term, I need my number of terms. What's your first term? What's your last term? Negative 100. How many terms you got? 25. Does everybody see why I call this an easy problem? It's an easy problem because I've given you exactly what you want. Right? You want first term, last term, number of terms. Right? And then it's pretty easy. You can type that in your calculator, so it's going to give me 25. Oh. That number's kind of is uglier than I was expecting, but so 25 times, what's that? Negative 69 divided by 2, and whatever number that is. Is everybody okay? So even though the number's ugly at the end, like normally you get nice integers, even though this number isn't as nice as we'd like, we understand what's going on, right? So if I give you exactly what you want, you go, great. All right, well, what if I don't give you exactly what you want? Like, for example, what if I want to know S of 20, and then I tell you that A sub 1 is equal to negative 2, and that your common difference, copied that wrong, A sub 1 is 7, and your common difference is negative 2. All right. So I'm not quite giving you exactly what you want. All right? Just because I don't give you what you want, right? You still need first term, last term, number of terms. So let's talk about what we've got so far. What's our first term? 7. Okay. Do I know the last term? How many terms do I have? Are we okay? We got 20 terms? And so this is 20, and this is divided by 2. And we need the last term, don't we? Right? Well, how do you find the last term? Oh, y'all remembered. Tears. Got the warm feeling. That's awesome. All right. We write our explicit formula. And so A sub n equals, so what's my explicit formula? Oh, you already figured out the last term. Oh, no, A1. Oh, okay. Well, I do it with my common difference is negative 2. So A sub n is going to be negative 2n. And now I need to fix it, right? What needs to go here so that my first term's a 7? Plus 9. Does everybody see that if I plug a 1 in, I'm going to get a 7? So now I have my explicit formula. Yay! Do I have enough information so that I could find my last term? So now if I plug in 20, okay, so negative 2 times 20 plus 9, so negative 40 plus 9. Everybody okay with 31?
Negative 31.
Thank you. Did that make sense? And then it's easy, isn't it? Right? We just plug it in. Actually, that one's really easy because 2 goes into 20 10 times. 7 minus 31 is a negative 24, and so we end up with negative 240. Did that make sense? And then all of this hinges on the fact you need 3 things. You need the first term, the last term, and the numbered terms. And I'm going to go ahead and tell you that my examples, I'm going to leave out one of these, right? So I left out the last term, right? We had to figure some stuff out, right? How it gets harder is when they start leaving certain things out. Well, what if find the sum of this? So I'm going to give you 12 plus 19 plus 26 plus dot, 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 plus 180. All right, first, can everybody recognize that's an arithmetic series? Series because we're adding up, right? Arithmetic because your common difference is 7, right? So what do we need? What do we need to sum up this series? What 3 pieces of information do we need?
First, last, and number of terms.
First term, last term, number of terms. What's your first term?
12.
That was tough, wasn't it? That was real hard. So this is going to give me, so I know it's going to be 12. What's my last term? 180. Boy, that was tough too, wasn't it? What are we missing? I'm missing the number of terms. Does everybody see we're missing the number of terms? Well, So how do we find the number of terms? What do you need?
Do 180 equals 7 plus 5.
Yes. You skipped a step, but that's good. What do you always need? When you're dealing with an arithmetic sequence, what is the key thing that you need to answer any tricky problem? The common difference, so that you can find the explicit formula. Do you remember all those problems we did with an arithmetic sequence? You always need the common difference so that you can find your explicit formula. And once you have your explicit formula, then you can answer any question. Okay? And everybody already told me my common difference is 7, right? So if my common difference is 7, my explicit formula is going to be a sub n is equal to 7n. What needs to go here so I get a 12? Plus 5. Now, how is that helpful? Can this tell? Could this help me find that position? Like this is position 1, 2, 3. This is position n. You remember having problems where you had to find like what position in a sequence? If this is the value, how do you find the position? So if this is the value, this is going to give me 180 is equal to 7n plus 5, and now I solve. Yes. Oh, no, you're just playing. Okay. So I get 175 is equal to 7n. Divide both sides by 7. Please let this be a nice number.
It's 25.
Awesome. Well, of course it's 25. I should have done that in my head. And so I end up with n is equal to 25. And so what do we know? We know there are 25 terms. Does that make sense? Right? And all of this is about when you're asked to find, a sum of an arithmetic series, you know your first term, your last term, your number of terms. And then how do you use the formula, all right? Last example. what if? I'll tell you a sub 1 is equal to negative 4. I'll tell you the last position is equal to 8. And then I'll tell you the sum of everything is equal to negative 144. And here. I want to know the second position. And I may have messed up. Wait. Make sure I copy this around. That doesn't. I'm thinking I left off a digit. In fact, I know I left off a digit. Do apologize. Dang it. My notes don't make sense on that. I'll say a sub 1 is 7. I'll say a sub n is 79. And I'll say the sum of the is 430. Okay. Just looking at my notes, and my notes didn't make sense. Okay, same type of problem, but I messed up with the numbers. And I still want to know what's the second term. Well, at first glance, this seems like it should be easy, shouldn't it? Like if I give you the first term, right? And I know it's arithmetic, you just need to find your common difference and you know what your second term is, right? The problem is, do we know exactly what our second term is? And a lot of that hinges on the fact we don't know, we don't know what our common, we got to find our common difference, right? So what do? Can we find the number of terms? So let's plug in what we know. We've got our formula. It says we know the formula is 430, right? The sum is 430, and that's going to equal what?
N.
So n, and then what's going to go in here?
7 plus 79.
7 plus 79, all over 2. Does that make sense? And, well, you could solve that, can't you? My suggestion is 7 plus 79 is 86. And so I end up with 430 is equal to 8, ends up being 43n. So how many terms do we have? Yeah. So I end up with n is equal to 10. Great, I know it's 10 terms. Well, if I know it's 10 terms, how does that help me? How does that help me figure out what my common difference is? Well,
Because you can plug in 10 for n in the explicit formula.
right, you can find your explicit formula. Like you can go through, like in my mind, what I see is I think of that 7 as the first position, and now I know that's the 10th position. Well, could I find my common difference now? Because with an arithmetic, we could do the slope thing. So I can do this minus this, so that's going to give me 72 over 9. What's my common difference?
8.
8. And so that gives me an 8, which is my common difference. So if my common difference is 8, what's my second term? 15. You see how I'm trying to pull in what we talked about with arithmetic sequences? So it's not enough just to know this formula. You have to know all the other stuff. All right.